vector product. In previous lecture, we complete 5 characteristics of vector product, and today we are going to study characteristics number 6. Characteristics number 6. The magnitude of cross product of two vectors is numerically equal to area of parallelogram whose adjacent sides represents two vectors. This is the characteristics number 6. Now we have to show that the cross product of vector P and vector Q is the area of parallelogram. So we write here in this diagram vector OA, let vector OA is equal to vector P and vector OB is equal to vector Q. Now from point B there is a perpendicular on a vector OA. So BD is perpendicular on a vector OP or vector OA, and this BD, that means height BD is equal to H. From B to D there is a height H. Now OACB is the parallelogram. OACB is the parallelogram, and we know that area of parallelogram of parallelogram is equal to base into height. What is the area of parallelogram? Base into height, which is equal to base, that means OA multiplied by height, that means this side BD. OA multiplied by BD. We know that vector OA is equal to vector P is equal to vector P and side BD. Now BD is equal to H, but in a triangle ODB, in a triangle we have to find out the value of BD. For that we consider triangle. OBD. In a triangle OBD, we have to find out side BD. Therefore, this angle is theta, and now sin theta is equal to BD. Sin theta is equal to BD divided by OB. BD divided by OB. Therefore, BD is equal to OB sin theta. OB sin theta, which is equal to OB means vector Q. Therefore, vector Q sin theta. BD is equal to vector Q sin theta. Therefore, substitute this value in this formula or in this step, we get area of parallelogram is equal to OA means P and BD, that means H, is equal to Q sin theta. PQ sin theta, which is equal to PQ sin theta. And we know that this is the magnitude. PQ sin theta is the P cross vector Q, and this is the characteristics number 6, that we are going to show area of parallelogram is equal to cross product of two vectors, vector P cross vector Q, and these characteristics separately asked in an exam for 2 marks. So we prove this area of parallelogram is equal to cross product between two vectors. Let's see again. This is the parallelogram OACB. From point B, we take a perpendicular on side OA. Side OA is equal to represent vector P, OB represent vector Q, BD is perpendicular on a vector OA, and we get BD equal to H1 height. Now area of parallelogram is equal to base multiplied by height. So from this parallelogram, base, that means side OA, and height, that means side BD. OA means vector P cross vector H. Now from triangle, vector height H. Now we have to find out this side BD. From triangle OBD, this right angle triangle OBD or ODB, sin theta is equal to BD divided by OB. Therefore, we get BD is equal to OB sin theta, which is equal to vector Q sin theta. Substitute this value in this equation. OA is P and BD, we get Q sin theta. So PQ sin theta, and we know that this is the magnitude of product of two vectors, vector P and vector Q. In this way, we get area of parallelogram is equal to product of magnitude of two vectors. So up to these characteristics, our chapter number 2, mathematical methods theory part, is completed. Now we are going to study the exercise on this chapter. या पॉइंट पर्यंत किंवा या कॅरेक्टरिस्टिक्स पर्यंत तुम्हाला थेरी पार्ट जो आहे तो थेरी पार्ट इथे संपलेला आहे. थेरी पार्ट मध्ये कॅरेक्टरिस्टिक्स आणि जे काही डेरिव्हेशन्स आहेत ते डेरिव्हेशन्स तुम्ही लिहून काढायचे आहेत. त्यामध्ये काही डाउट्स असेल तर विचारायचे. ठीक आहे. नेक्स्ट पॉइंट जो पाहणार आहोत आपण, that is exercise on this chapter, mathematical methods. First, choose the correct option. Choose the correct option. In first question, there are MCQs, 5 MCQs. First MCQ we are going to study. I read here first MCQ. The resultant of two forces 10 Newton and 15 Newton. The resultant of two forces 10 Newton and 15 Newton. Here is 10 Newton and here is 15 Newton. Acting along positive and negative axis respectively. Positive x-axis and this is negative x-axis respectively is there is an option given 25 Newton along positive axis, 25 Newton along negative x-axis, 5 Newton along positive x-axis and 5 Newton along negative x-axis. The answer of this first MCQ is negative force minus 5 Newton or 5 Newton along negative x-axis. Option number 3, 5 Newton along negative x-axis. Negative x-axis. See here is 10 Newton and here is 15 Newton. These two forces are opposite to each other. So that resultant, when two forces are opposite, we call it as the anti-parallel forces, and these are same type of vectors. Therefore, we can add it as minus 15 Newton plus 10 Newton. We get minus 5 Newton. Since if this is a F2 and this is a F1, then F2 is greater than F1, that means negative force is greater than positive force. Therefore, we get minus 5 Newton. That means our resultant is along negative x-axis. Therefore, our answer is 5 Newton along negative x-axis. This is the first MCQ. Second MCQ, I read here on a page number 29. Page number 29. Second MCQ, for two vectors to be equal. For two vectors to be equal, they should have to be equal. They should have, and the option is first option same magnitude, B same direction, C same magnitude and direction, C same magnitude and direction, same magnitude and direction, and D same magnitude but opposite direction. Now see, in this sentence we are given for two vectors to be equal. That means the given two vectors are equal vectors, and we know that by definition of equal vectors, if the given two vectors of the same type having same magnitude and same direction, so our answer of this MCQ is same magnitude and same direction. Option number C. Now third MCQ. MCQ number 3 on page number 29. The magnitude of scalar product of two unit vectors perpendicular to each other. Scalar product of two unit vectors. For example, this unit vector I cap and this is the unit vector j cap. These two unit vectors is perpendicular to each other, and the scalar product, the magnitude of scalar product. We know that scalar product, that means we write as A dot B is equal to AB cos theta. AB cos theta. If theta is equal to 90 degree, we know that theta 90, that means 0. So we get here as our answer is 0, and same as for the unit vector I dot j cap, I cap dot j cap is equal to 0. So for and their option is A is 1, B is 2, C is 3 by 2 and D is root 3 by 2. The vector product, the magnitude of vector product of two unit vector I cap and second unit vector is j cap and the angle between them is 60 degree. Angle between them is 60 degree. We know that I cap vector product, that means I cap cross j cap is equal to I cap j cap into sine of theta. This is the magnitude of cross product between two unit vector. Now angle is 60 degree and we know that sine of 60 degree is equal to root 3 by 2. So our answer is mod of I cap is 1, mod of j cap is 1. So our answer is root 3 by 2. So option number D, root 3 by 2 is the correct answer. Next, MCQ number 5. If vector A, vector B and vector C are the three vectors, then which of the following is not correct? First, A option is vector A dot vector B plus C. Vector C is equal to vector A dot B plus vector A dot vector C. Option number B, vector A dot B, vector A dot vector B is equal to vector B dot vector A. Option number C, vector A cross vector B is equal to vector B cross vector A. Now A, B, C, we have given three vectors. Then which of the following is not correct? Is not correct. A dot B plus C is equal to A dot vector A dot vector B plus vector A dot vector C. This is the associative property of vector addition. A dot B is equal to vector B dot A. Commutative property of vector multiplication. Vector A cross vector B is equal to vector B cross vector A. We see that in characteristics of cross product, the commutative multiplication or commutative property of vector multiplication is not obeyed for cross product. So this option number C is not correct. Vector A cross vector B is not equal to, and in option C there is vector A cross vector B is equal to vector B cross vector A. This is the incorrect option. So option number C is the correct for this statement or MCQ number 5. So next question is, show that there is a distributive or destructive type question. Question number 2. In the first question, show that we have to show that vector A is equal to I cap minus j cap divided by question. We know that vector A is equal to mod of vector A. That means we have to get magnitude of given vector, and for this we write this A vector A is equal to, we simplify this as I cap divided by root 2 minus j cap divided by root 2, which is equal to 1 divided by root 2 I cap minus 1 divided by root 2 j cap. So here we get 1 divided by root 2 square minus 1 divided by root 2 square. We have to find out the magnitude of the given vector A. From magnitude, we have to decide or we get the answer if vector A is a unit vector or not. So let's simplify. Square root of 1 upon root 2 square, that means 1 divided by 2. Then minus 1 upon root 2 square minus then it becomes plus. So here is minus 1 upon root 2, here is plus sign, therefore plus minus 1 upon root 2 square, that means 1 upon 2, which is equal to square root of 2 divided by 2, which is equal to square root of 1, that means 1. So we get the magnitude of vector A is equal to 1. Therefore, given vector A is a unit vector. Given vector A is a unit vector. We know that unit vector having magnitude 1. That vector we call it as a unit vector. So in this way we get the value or magnitude of vector A. If this question is asked for 2 marks in exam, first you have to write this formula, then substitute the values and then get the answer. That means magnitude of vector A is equal to 1. Therefore, vector A is a unit vector. Next question. Question number 2 is question number 2. If V1 vector V1 is equal to vector V1 is equal to 3I cap plus 4j cap plus k cap, and phi2 is equal to vector phi2 is equal to I cap minus j cap minus k cap minus k cap. Determine the magnitude of determine the magnitude of vector phi1 plus vector phi2. We have to determine its magnitude. So solution, vector phi1 plus vector phi2 is equal to 3I cap plus 4j cap plus k cap plus v2 I cap minus j cap minus k cap, which is equal to, now simplify this to cap, j cap and k cap terms or unit vectors plus 1 minus 1 k cap. 3 plus 1 4 I cap plus 4 minus 1 3 j cap. 1 minus 1 0. So the last unit vector is 0. Here we get vector phi1 plus vector phi2 is equal to 4 I cap plus 3 j cap. Now we have to find out the magnitude of vector phi1 plus vector phi2. So for the magnitude we write this vector as vector phi1 plus vector phi2. Mod of these two vertical lines we call it as a mod. Therefore mod of vector phi1 plus vector phi2 is equal to square root of 4 square plus 3 square, which is equal to square root of 60 plus square root of 4 square 60 plus 3 square, that means 9, which is equal to square root of 25. And to know that mod of vector phi1 plus vector phi2 is equal to 5. This is the magnitude of vector phi1 plus vector phi2. We get the answer as a 5. So next question number 3. Question number 3. For phi1, vector phi1 is equal to twice I cap minus 3 j cap, and vector phi2 is equal to minus 6 I cap plus 5 j cap. In this numerical, we have to determine the magnitude and direction of vector phi1 plus vector phi2. We know that for magnitude we write as vector phi1 plus vector phi2, and then we have to take the square root of these two vector addition. So first we have to add these two vectors, vector phi1 plus vector phi2 is equal to twice I cap minus 3 j cap plus minus 6 I cap plus 5 j cap, which is equal to, now twice I cap and minus 6 j cap to minus 6 I cap plus 5 minus 3 j cap, which is equal to minus 4 I cap plus twice j cap. Let's take magnitude of these two vectors. Vector phi1 plus vector phi2 is equal to square root of minus 4 square plus 2 square, which is equal to square root of 16 plus 4, which is equal to square root of square root of 20. We can write it as a 5 multiplied by 4, and we know that square root of 4 we get 2 outside 2 square root of 5. So we get the magnitude of vector phi1 plus vector phi2 is equal to 2 root of 5. Now we have to find out the direction of vector phi1 plus vector phi2. This will be continued in tomorrow's lecture. For today we stop here. Thank you.